Welcome to Module 1.2.1.1, where we're talking about different types of bonds that you might find in chemistry. So first, you might ask yourself, what is a bond? Well, you can really think of a bond as a kind of glue that holds all of these different molecules together. And the glue is really an electrostatic force between different charged objects. You say, what the heck does that mean? Well, it has to do really with something called Coulomb's law. Okay, Coulomb's law says that things with opposite charges tend to attract each other, and things with the same charge tend to repel each other. Okay, and so you have these different opposing factors. Okay, for example, the protons and the electrons are attracted to each other, but the electrons repel each other, and the protons repel each other. So you have what's called a minimum in a potential energy diagram, where these forces are perfectly balanced between the attractions and the repulsions, and they give you kind of the lowest energy possible. Okay, so when you're talking about different kinds of bonds that might exist, one type of bond is something called an ionic bond. Although some people don't really think of this as a bond, but rather more of like an electrostatic interaction. But at any rate, ions are things that have gained or lost electrons, and they can have either positive or negative charges. So as you know, cations are things that have lost electrons and have a net positive charge, usually from metals. Anions are things that have gained electrons and usually arise from nonmetals. You can also have what are called polyatomic ions, which are composed of just more than one atom. So here's a cation, here's the anion. Okay, so now what we're going to do is show you a picture of different types of bonded compounds. Okay, and so you can have nonpolar compounds that are made out of things with nonpolar bonds, for example, atoms or nonpolar molecules. And these are held together by what are called London dispersion forces or van der Waals forces. Polar compounds have polar bonds in them, so polar molecules. They still have dispersion forces, but they also have this new thing called dipole-dipole or dipole-induced dipole interaction. So these are attractions between things that already have a permanent dipole moment associated with them. A specific case of this, which gets its own little category, is called hydrogen bonding. And this happens when you have a hydrogen bonded to a very electronegative atom, right, nitrogen, oxygen, or fluorine, that happens to be next to another electronegative atom, like nitrogen, oxygen, and fluorine. Okay, and so nitrogen, oxygen, and fluorine happen to be the three most electronegative atoms in the periodic table. And the difference in electronegativity between the H, the N, or the O, and the F is so great that it gives rise to a very, very strong dipole-dipole interaction. So it becomes its own thing called a hydrogen bond. Okay, you also have something called a network covalent solid, where the atoms are actually held together by covalent bonds. This would be something like graphite or diamonds that are made out of carbon atoms. You can have ionic compounds that we talked about earlier that are held together by electrostatic interactions between cations and anions. So for example, something like sodium chloride. And the last one is a metallic bond or a metallic compound. So you find these typically in metals like iron or silver, copper, gold. And so what happens in these metallic bonds is you have not actually atoms, as you might expect, but cations and delocalized electrons. So what does that mean? Well, let's pretend that you had, I don't know, silver, okay, atomic silver. If you had a piece of silver in your hand that was metallic, you wouldn't actually see little silver atoms in there. What you would find are silver ions, because after all, silver likes to lose electrons like most metals do. And when it loses the electron, it gives the electron to its neighbor. The neighbor doesn't want it either, so passes it on to its neighbor, and 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 eventually goes all the way around to the entire crystal lattice, and the electron comes back to where it started. Okay, and so those electrons are moving around, and they're delocalized. And that is really why a lot of metals can conduct electricity, right? That movement of electrons is related to electrical conductivity. So even though the whole thing is neutral, I don't have individual atoms in there. I have cations, right? Positively charged ions in the middle with all these electrons spinning around. This is sometimes called the sea of mobile electrons.